Okay, today we're going to cover a topic called slope fields. Shout out to Avery's gone, and Ella's gone, and Michaela's gone, and who else is gone? Everybody? So we hope you guys are doing well, whether it be Winona or wherever. Hope you had a good time. This is stolen from Nancy Stevenson from Clements High School in Sugar Land, Texas, apparently. This is straight off the AP website. Actually, slope fields don't come up in your textbook at all. They're not even addressed. I never learned slope fields when I was in high school. Never learned them in college. First time I saw them is when I saw that we had to prepare for the AP exam. The good thing is they're really simple. Easy way to get simple points in the AP exam. Now, my Smartboard software is going kaput, if you can't tell, and so it doesn't print off all of the dimensions here. So we got dy, I'm going to rewrite it, dy over dx is equal to x plus 1, and I will give Hattie her sheet back. So, a slope field, what do? A slope field is a bunch of segments that have different slopes. The way we calculate the slope is right here. Dy over dx is just a fancy way of saying y prime is equal to x plus 1, or slope is equal to x plus 1. Those mean the same things basically, okay? So if I pick any coordinate up here, okay? For example, let's say I pick the coordinate 1, negative 2, right? So I'm just going to pick 1, negative 2. That's over 1 and it's down 2. Everybody agree? It would be on the red dot. So if I want to determine the slope field at that spot, all I do is I take the x value of the coordinate and I add 1 to it. What do you get if you add 1 to the x coordinate? So all you do is you just draw a segment that has approximately a slope of 2. Now I know you don't like that whole idea about approximately a slope of 2, but you know that's kind of the deal. And if I follow that same pattern, suppose I went over 1 and down 1. This still has an x value of 1, doesn't it? What's going to be the slope as long as there's an x value of 1? It's going to be 2. And here I have an x value of 1, so the slope is going to be, in fact, all the way up and down here, the slope is going to be 2. So I'm taking the x value and I'm adding 1 to it because it says take the x value and add 1 to it. Yep. What are all of the x values here? All the x values are 1, so therefore the slope will be 1 because you take 0 plus 1 and you get 1. So we're going to draw slopes of 1 through here. What are the x values here? Negative 1. So if you add the x value of 1 to negative 1, you get, so these slopes are all going to be 0. Thank you for thinking about that. I think we'll answer your question here in just a second. Now, if I were to look at this x value of negative 2, the slope will be, so I draw slopes of negative 1. Yep. Bruh. All right, this is an x value of negative 3, so you're going to have a slope of, yeah, and it's nice if you could kind of figure out a quick way to navigate through. Obviously, as you move over to 2, you're going to have a slope of 3, so I'm going to try to draw slopes of 3 and then slopes of 4. And after a while, you know, it's like, well, what's the difference between each of them? You can't really tell. Obviously, 0 and negative 1 and positive 1, you should be able to tell those really quickly, right? Yeah. So now we're going to give you a chance to see. So she said, is this all there is to it? Not exactly. I think Marissa hinted to what she sees it going towards, and maybe she saw it, maybe she didn't. But I want you to see that we're looking at a derivative. This is a differential. It says the derivative is x plus 1. So watch what happens if we take the antiderivative. What's the antiderivative of x plus 1? X squared over 2 plus x plus a constant, agreed? What shape does that make? A parabola. If you were to pick a spot on this graph, say I were to pick a spot here, and I would draw a graph that kind of had slopes similar to what's around me, what shape would it make? A parabola. Notice how you could draw a parabola there, or you could draw a parabola here, or you could draw a parabola here. They all have different constant values, don't they? Because we don't know the beginning constant. See my point? So your goal is to be able to draw a slope field, and then once you draw the slope field, be able to sketch a general graph somewhere through it. We'll get a specific graph after a different point in time. All right. Not unless it asks, you're just a little bit ahead of me for that. Okay. So let's look at this one. We've got dy over dx is equal to 2y. Okay. dy over dx is equal to 2y. So where would you like to start as you draw this slope field? Because we can draw this one fairly quickly. At 0, so you want to start right here. So that's the coordinate 0, 0. So what's the slope going to be? Marissa, would you like to head up and down, or would you like to head right and left? You want to head up and down, so the y value here is 1, so the slope will be 2. And then the y value here is 2, so the slope will be 4. The y value here is -1, so the slope will be -2. And the y value is -2, so the slope is going to be -4. Okay?
What I'm worried about is that I feel like my drawings give slope. Like
Nope. Trust me, as you'll actually sketch these at one point on the AP exam, and it's fairly forgiving. And as I grade the test, a lot of times people are worried my slope fields won't look right. They will. But to just make sure we're on the same page, I would not have chosen to, and that's okay that Marissa did, I would not have chosen to go up and down. I would have chosen to go left and right. Because all along this axis, the y value is equal to 0. So therefore, the slopes are all going to be 0. It's okay. Now, as I move up 1, the slopes are all going to be 2, because it's 2 times the y value. My y value for all these coordinates is 2. So I'm going to sketch a slope of 2 all the way through these. And then up here, I'm going to sketch a slope of 4. Down here, I'm going to sketch a slope of -2. And then -4. Harder to draw a graph that goes through there, isn't it? Yep. We're not going to try in this situation, but we are going to look at problem number 3, which is simply dy over dx is equal to x plus y. What I'd like you to do is I'd like you to spend about 30 seconds trying to get a few of them on your own, and then after 30 seconds, then you can talk with a peer. Try to spend 30 seconds on your own. Ready, set, go. Timer is set. Yes. No, start wherever you want. Okay, if you want to start conversing, go ahead. See if where you're at. See what you're figuring out. Are you noticing something? I meant to do 3, but that's okay. Oh, okay. All right.
So if I go start like 0, 0, then it would be 1 plus 1. So the slope would be.
No, it'd be 0 plus 0.
Oh.
You're plugging in 0 for x and 0 for y.
Okay.
Good, you got it. Yep. Take about 45 more seconds, look through it. So we're just going to pick a spot. Yep. So 0 plus 1 is 1. 1 plus 2 is 3. 1 plus, or 2 plus 1 is, or I'm sorry, 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. Yep, you got it.
So is it like just the result of?
But along this axis, 0 plus 1 is 1. And 0 plus 2 is 2. And see what I'm saying?
Oh, so it's just the result of the right equation. Right. The answer to that.
Yep.
Okay.
Okay, 5, 4, 3, 2, 1. Let's talk together. I'm just going to pick each point. As I pick a point, I add them together. So 0 plus 0 is 0. 1 plus 0 is 1. 2 plus 0, 2. And then 3. And then negative 1, negative 2, negative 3. Right? Now, as I think about this, I'm going to come up with something that's kind of creative. If the x and y values are ever opposites, then it's going to be 0, right? In which quadrants are the x and y values opposites? In the second and the fourth, right? So for example, like negative 1 and positive 1, I'll get 0 there, and I'll get 0 there. And then positive 1 and negative 1, I'll get 0 there and 0 there. And then I could just start to build other slopes all the way throughout. For example, this is 0, 1, so I'll have a slope of 1. 0, 2, slope of 2. Over here, I have 1, 1, so that will be a slope of 2. 1, 2, so I have a slope of 3. And you can see how you could just continue to pick points and add them up over and over, right? On your AP exam, you usually have about somewhere between 8 to 12 dots that you're finding the slope for. So we're going to stop right there because we've done about 8 to 12. Number 4, tell me how to navigate this one a little bit quickly. Where is x equal to 0? Along the x-axis or along the y-axis? Along the y-axis, x is equal to 0. So therefore, I have 0, 0, 0, 0, 0. What is true about all of these coordinates here? X is 1, so therefore the slope will be 2. All along here, x is 2, so the slope will be 4. As I back up 1, the x value is negative 1, so the slope will be negative 2. And we'll pause there. I think you get the idea, don't you? Okay. I don't want to do all of these. I just want to talk quickly about them. What y value would give you 0? A y value of 1. Where is there a y value of 1? Where is there a y value of 1? Isn't this the spot where y is 1? So therefore, all across here, I will have slopes of 0. How about when y is 2? What's the slope?
1.
So I'll have slopes of 1 all the way across. And down here, I have y equal to 0, so therefore the slope will be negative 1. And we don't need to worry about number 6. It is kind of cool, but we're a few minutes behind on that clock for where I want to be, so let's go here, okay? Is number 10 just x? Yeah. So what you want to do here is you want to try to match the slope fields with one of these 4 equations. So for example, one of these is 2 minus y, which means that the slope is going to be equal to 0 whenever y is 2. Go ahead and see if you can match them. Try to match them. Talk together, see if you can do some matching. Go. So we're looking for a slope equal to 2 minus y. So if you have y equal to 2, then the slope would be 0,
Why
right?
you set it equal to 2?
What's that?
Why do you set y equal to 2?
You don't
Like,
have
I'm
to.
not gonna set sine equal to.
Sure. I just chose 2 because I can see that 2 minus 2 is 0. It seems like a quick way to look at it.
Oh, okay.
So is there a spot here where when y is 2 that the slope is 0?
This one?
If you go from here, you go up 2, 1, 2. Notice how all these lines have a slope of 0 right there?
Yeah, it's a nice. Oh, like all of them.
Yeah,
That
all of
way.
them.
Oh,
All of them.
oh, okay. Yeah, then.
This one is x. So it's like when you're at the point of, so it means when x is 1, all the slopes are 1. When x is 0, all the slopes are 0. When x is 3, all the slopes are
So
3.
you can pick any number for x.
Sure, yeah. Just as a coordinate and see what it matches to. You guys got good guesses? Let's try to check them. I started with this one right away, the 2 minus y. If you notice, this graph right here, this is the spot where y is equal to 2. So that's going to produce 0 slope. So therefore, letter A, that matches with number 10. Oh, I'm sorry, with number 9. Sorry about that, yep. All right, the second one, I look at number 10. I like that because it says x. And if you notice, what's the antiderivative of x? X squared over 2. So that means that the graph should make a parabola. Which one up here is going to make a parabola? B is. And if you look at it, when there's an x value of 1, the slope is 1. When x value 2, slope is 2. X value of 0, slope is 0. So that convinces me that this is letter B right there. So I've got that one good to go. Now I got to figure out these two right here. I like to focus on the x minus y. That means that when the x and y values are the same, the result will be 0. If you look here, whenever x and y are the same, I'm getting a slope of 0. So therefore, D matches to number 8. And watch how cool this is. What's the antiderivative of sine? Negative cosine. If you were to draw a graph through here, isn't that what you get? This is letter C. Try 4 more. Go. Which one do you want to start with? Let's start with this one.
Okay.
What would produce a 0 slope when x and y are?
0.
When they're both 0? Yeah. What when they're opposites? So like 2 and negative 2?
Because you divide.
Or just 2 plus negative 2 is 0? 4 plus negative 4 is 0? So like if you have a coordinate of 3, negative 3, or negative 2, positive 2, that would produce 0 for a slope, right? Do you see an example here where you have that happening? To where whenever there's opposite coordinates, you're getting 0 for a slope.
Like, shouldn't there be like 2 spots with zeros?
Right here. In the second and fourth quadrant, x and y are opposite values.
Oh.
And so A goes right there.
I was looking for like 2 lines.
Look at right here, when y is 0, then you have a slope of 0, right?
Mm-hmm.
So we want to look for a graph when y is 0. So y is 0 right here. So are all those slopes 0? No. Are all these slopes 0? Actually don't have a slope listed, do they? There is no slope there.
Nothing.
Are all the slopes 0 here?
Is there nothing there?
There's actually you can't see them, but there are slopes there. So yeah, so this is going to be, and let's just check. Let's move up to one spot. If y was 1, then the slope would be a half, right? Does that look like about a half? And if y was 2, then the slope would be 1. Does that look like about 1? Looks like C matches right there. What did you think about the 2 others? Everybody got guesses? So I went to problem number 14, and I said that x plus y, if they were opposites, I would get 0. And so I noticed that right here, I have opposite values, and they produce 0. I'm going to say that this is letter A. I also noticed I like this one right here because I just take y and multiply it by 0.5. Now it's hard to tell here, but in this example, there's no slope fields drawn, whereas in this example, they're all flat. So it's really hard to see that, and I apologize, but that's the way it's shaped. So if you notice, y is 0, and then when y is 1, you get slopes of a half. When y is 2, you get slopes of 1. When y is negative 2, you get slopes of negative 1. So C matches right here. What happens when y is 0 in this situation? It's undefined, which means you would have a vertical line or vertical slope or no slope line shown anywhere where it's 0. This one definitely matches to there. And you are right, it is a circle. And so then the last one, 0.5x minus 1, if I take the antiderivative of this, am I going to come up with x squared? Yeah, and doesn't this fit the shape of a parabola? Yeah, so B is going to be this one right here. Okay. Good job. You're almost done. Flip it over. Okay, so I can't read the directions because it didn't print off, and it says the slope field from a certain differential equation is shown. Which of the following could be the specific solution to the differential equation? So if you draw this, a graph here, okay, would you guys agree that this might be kind of the general shape that flows through there? Okay, all right. Is that the graph of x squared? No, it's not. Is that the graph of e to the x? No, kind of close, but not quite right. E to the negative x looks like that. Is that the graph of e to the negative x? Is that the graph of cosine of x? Is that the graph of natural log? Yes, natural log is the correct option. Okay. See if you could pick 16 on your own. This is your last one for the day. Try to pick 16 on your own. If you were to draw a graph through there, which one would it match up with? Try to pick that one on your own. I have that as the shape of the graph. It is a cubic. It is a cubic that goes through there. It's a cubic. Okay. All right. Please look at your homework.
How come when you said you did the antiderivative of x squared on the other side, you just said you did the graph left?
So just to be clear, here you're given y is equal to cosine of x, right? So you're not being given dy over dx is cosine of x. So you're already being given the antiderivative. You see what I'm saying? All right. Now, what I want you to do, you don't have to necessarily fill every dot, but do 12 of them. And then the back side is just matching. Okay? Back side is just matching. Monday and Tuesday, it takes 2 days for the lesson. 2 days for the lesson. I'd like to test next week, Friday. We have one lesson left. Have a good day, sir. Good luck in your skating.
Yeah, I know.
See you practice, bud.
Yeah.